I'm Math Dad.
I'm Science Mom.
Today we're talking about shapes and their names. So we're classifying triangles and quadrilaterals.
Ooh.
Do you remember what a quadrilateral is?
Something with four sides, but I have to say I'm excited to see this topic because I do not remember the difference between a rhombus and a trapezoid, and those always confused me when I was in school.
All right, well, we will get to that topic today. So first of all, Science Mom, can you draw an acute triangle?
Yes, an acute triangle is going to be one that has large eyes and funny eyebrows and a little smile. Look at that. It is a cute triangle.
That is a very cute triangle, but an acute triangle is different. But you actually did draw an acute triangle.
Because it has an acute angle, one that's smaller than 90 degrees?
Yes, but all triangles have an acute angle. All three angles have to be acute angles for the triangle to be an acute triangle. So try drawing another one. Let's see if you've got it.
Okay, acute triangle. I'm going to draw two more.
Okay.
Ooh, hold on. Sorry.
All three angles are...
Let me try that again. How'd I do? Are those are acute?
Those are acute triangles because each of the angles is less than 90 degrees. I will say this one might look like it's almost 90 degrees, but I think you squeezed it in there, Science Mom.
Phew.
Just barely. All right. What about an obtuse triangle?
An obtuse triangle needs to have an angle that is bigger than 90 degrees.
That is correct. So, you think you can do it?
I can do it.
She's ready. Put me in, Coach.
There's an obtuse angle, and now we just connect it, and it is not a cute triangle.
I like that a lot because you drew the angle first, and then you said, I'll just connect the other side, and regardless of how you connected them, as long as you connected the endpoints, you had an obtuse triangle.
Woohoo!
All right. What about a right triangle?
For that, we need a right angle. And it's a right triangle whether we draw it like that or like this. Doesn't matter how long those sides are, as long as it has a right angle, it's a right triangle.
That's right. Could there be two right angles?
No. Because if you had two right angles, then you can't connect them with two sides.
Yeah, that's right. Yeah, a triangle can't have angles that are that big. No, not two of them. Okay, there's another way of classifying triangles based off the lengths of the sides. So an equilateral triangle is a name for a triangle that has three equal sides.
Hence, equilateral.
Yeah, that's exactly where the name is coming from.
I'm going to try and draw one. This is kind of tricky. I want to try and make the sides all the same.
Yeah.
How does that look?
Well, that looks pretty good. I don't think I could do any better.
This is equal to this is equal to this. They're all equal.
That's right. If you rotated this a third of the way around, it would actually look the same. So that's a really neat property about equilateral triangles. They have extra symmetry in them, that rotational symmetry. All right, what about an isosceles triangle? Isn't that a great word, isosceles?
It is, especially because I know what it means. It's Greek, it's from Greek roots, and it means iso, same, and then skelos is for legs. So two legs that are the same length. It means that there are two sides that are the same.
That's right, so an isosceles triangle has two equal length legs.
So that one is equal in length to that one. That's right. Isosceles.
Yeah, very nice. All I know is I have trouble spelling the word.
It's not an easy one to spell.
No. All right, and then our third type of triangle, a scalene triangle. So we had three equal sides for equilateral, two for isosceles, and for scalene triangles, there are no pairs of equal sides.
No equal sides. It is not easy to draw under pressure.
There we go. I like it. So all three sides have a different length, and that's a scalene triangle.
This is harder than I...
That's not even a triangle, Science Mom.
When I concentrate on wanting the sides to be different length, then I get nervous that I'm actually drawing a isosceles triangle instead.
Yeah, it's hard to draw them so that they're clearly distinct lengths sometimes. But yeah, I think you handled it well.
I think I did it.
Okay, so now we had those different ways of classifying the triangles. You could classify it based off of the angles, so the right triangles, obtuse triangles, and acute triangles, or you could classify it based off the side lengths, equilateral, isosceles, or scalene. So my question is, which could go together? So for example, if you have an equilateral triangle, could it also be, at the same time, a right triangle?
No,
No?
I don't think so. Because an equilateral triangle, the way that we drew it, when I carefully drew out to make sure that all the lengths are the same, if it had a right angle, then this part right here is going to be longer than the sides.
That's exactly correct. For a right triangle is going to have the side that's opposite the 90-degree angle as the hypotenuse, we call it. It's a fancy term, but it's always longer than the other legs. So, all right, equilateral triangles cannot be right triangles. Can they be obtuse?
Nope, I think they have to be acute.
They do have to be acute, yeah. There's not a lot of flexibility with equilateral triangles. All right, Science Mom, I'm going to have to confiscate the pen. All right, yeah, but that's what we're doing here. We're drawing lines to connect. So equilateral can be acute, and that's all they can be.
Only acute.
Yep. All right, what about an isosceles triangle?
That one can definitely be right.
Can you draw me an isosceles right triangle?
Yes. So I'm going to make this side the same length as that side. Ta-da! And now I just need to connect to them, and that's an isosceles right triangle.
Excellent.
And using that same logic, we could also make an obtuse. Pretend like those are the same. I don't know if they actually are.
Okay. Make those the same length. Okay, she tried.
I tried.
And then can an isosceles triangle be an acute triangle?
Yes.
All three.
All three.
So draw those lines connecting them. Okay, what about a scalene triangle? Can a scalene triangle be a right triangle?
I'm not sure.
You've actually drawn some already. If we went to the last slide, when you did your example of a scalene triangle, you actually did draw a right triangle.
So if we just adjust, because we know that we can do all three of the isosceles, if we just adjust the lengths slightly, then we can get scalene with all of them, right?
Okay, so let's see. So here was maybe a right triangle that was a scalene triangle. Can it be obtuse and scalene? Oh, I see what you're saying, Science Mom. You're saying grab this point and drag it to the side just a little bit.
Yeah, and then in just a little bit.
Or this way just a little bit. Yeah, I like that.
Those are all scalene triangles.
Yeah,
so
although this last one, it's hard to tell that the two sides are not the same length. But yes, a scalene triangle could be a right triangle, it could be an obtuse triangle, or it could be an acute triangle. So now we're talking about quadrilaterals, which are four-sided figures. Triangles had three sides, quadrilaterals have four sides. And basically, if I draw any 4 points in the plane, I could connect them, and whatever I get when I connect them in a nice cycle is a quadrilateral.
Ooh, even if it's not a rectangle, not a square? It can have any shape as long as it just has four corners?
That's right. And so squares would be an example of a type of quadrilateral. And my guess is you're pretty good with squares, but I bet you don't know a trapezoid. I think in Britain they call these trapeziums, which really confused me when I was reading about this.
So can we start at the bottom and work our way up? Because you're right, trapezoid and parallelogram and rhombus, I don't remember what those are. But I do know what a square is. A square has four equal sides.
Okay, a square does have four equal sides, although that's not enough.
That's not enough?
No.
Oh, the square has four equal sides and four right angles.
Yeah, so four equal sides and four equal angles.
Ooh.
So
that is a square.
That's a square behind my head there. It's almost like a halo. Square halo? No? All right. What about a rectangle?
A rectangle has two equal sides. And it has four equal angles. The angles are equal, but you can stretch it out. So it's like a stretched out square.
Four equal angles.
And that's it? That's all you need to know?
Yeah, and as a consequence of that, though, the opposite sides are going to be parallel to each other, and they'll have the same length.
So is a square also a rectangle?
Is a square a rectangle? Yes, it is. All squares are rectangles. What about, are all rectangles squares?
Nope.
Oh. All right, a rhombus. So this is one that we probably don't come across every day, at least not using the language So a rhombus has an interesting property, 4 equal sides.
But it doesn't have to have 4 equal angles.
Nope. If a rhombus has the 4 equal sides and also has 4 equal angles, then it's a square.
So a diamond is a rhombus?
Okay, yeah, let's draw these. I should have done this. Oh man. There's a rectangle, and yeah, a rhombus. I like that. So you're saying. So if all 4 of those segments are the same, then that's a rhombus. I like it. And we'll come back to some more examples. A parallelogram.
Has sides that are parallel?
Yeah, opposite sides are parallel. That's exactly what you get for a parallelogram.
But the angles don't have to be equal.
Nope, the angles don't have to be equal. And in fact, I'm going to draw this long, narrow parallelogram here, just because I can. But yeah, opposite sides on this are parallel to each other.
Do the sides have to be the same length?
That will be a consequence of this definition, that when the opposite sides are parallel, then opposite sides do end up being the same length. Okay, and then a trapezoid.
It's a trap.
It's a trap. It's a trap. All right, so a trapezoid has just 1 pair of parallel sides. Or I'm going to write it this way. I'm going to say at least 1 pair of parallel sides. And it turns out there's actually not agreement. Some textbooks that you look at will say that there should be only exactly 1 pair of parallel sides. I prefer the definition of at least 1 pair of parallel sides because I like to think of parallelograms as special cases of trapezoids, because all the formulas are still going to work just fine. So yeah, there's really no reason to break it apart. But just so be aware, not everyone agrees on that definition. And if it doesn't have any of these properties, well, we could still call it a quadrilateral.
Can you draw one that doesn't have any of those properties? I'm having a hard time picturing it.
Yeah. So let's do something like this.
So that would be a quadrilateral, but it's not a trapezoid because it doesn't have any parallel sides. And it's not any of the others because it doesn't have equal sides or equal angles.
That's right.
Okay.
Okay, Science Mom, I have a riddle for you. What starts with a P, ends with an E, and has thousands of letters?
Oh. What's that? There's a longest word in the English language. What is it?
Pneumona ultramicroscopic silicovolcaniconiosis?
Does that start with a P?
It does.
But that's not going to have thousands of letters.
No, it's not.
I'm stumped. What's the answer?
Post office.
Oh, that's clever because it contains thousands of actual letters, envelopes.
And packages.
Very nice. I like it.
All right, Science Mom, I'm going to hand over the pen. I want you to classify each triangle. And remember, we had the classifications based off angles and off the lengths.
Okay, so this one is acute because it has all acute angles and the sides are equal, so it's also equilateral.
Nicely done. It's an equilateral triangle. And those can only be acute.
This one is not a right angle and none of the sides look to be equal, so it is a scalene triangle, but all of our angles are acute.
I like it. It's an acute scalene triangle.
This one is obtuse because of this big angle right here, and I don't think all those are equal, so I'm going to say it is also scalene.
Nicely done. It's an obtuse scalene triangle.
And this one, that looks like a right angle, and this looks like it is equal to that. So I'm going to say This is a right isosceles. But I did not spell isosceles right.
No, but you tried.
I tried.
That's what's important.
And that's what counts.
Yeah, it's an isosceles right triangle. All right. Can you classify each quadrilateral?
Ooh. This is a rectangle
Nice.
because it has parallel sides and it has all the angles the same.
So the part that mattered was that the 4 angles were right angles. So
Okay.
4 equal angles.
4 equal angles.
So is it correct to call this a parallelogram?
Yes.
Yeah, it is a parallelogram. But it's an even more accurate answer, a more special deterministic answer would be to call it a rectangle.
And this one is a square and also a rectangle, also a parallelogram.
And also a rhombus, if you want to call it that. So yes, this one was the trap. I thought I might fool you with this one because a lot of people look at this and say, oh, that's a diamond, it's not a square. So what makes that a square?
It has 4 equal sides and 4 equal angles.
Yeah, all 4 sides are equal and all 4 angles are equal. So it's both a rhombus and a rectangle, so it's a square.
Excellent. This one is a parallelogram because it has parallel sides, 2 of them.
Opposite sides are parallel.
And I think I spelled parallelogram wrong as well. Apologies. This one, it's a trap.
It's a trap.
It's a trap. It's a trapezoid. And it's a trapezoid because it looks like a trap, like you'd fall into it.
Okay, well, it turns out it's not a trapezoid.
Oh no, it was a trap. It was really a trap.
So, in order to be a trapezoid, we would need at least one pair of opposite sides to be parallel.
Oh.
And if you look at the opposite sides here,
So if it was like this, where these were parallel, then it would be a trapezoid.
that's right.
But it does not have 2 parallel sides, and so it is just a regular old quadrilateral.
Yeah, it's a quadrilateral, and that's the best we can do. We can't get any more specific than that. So a special thanks to our patrons for making this video possible. We appreciate your support. If you'd like to become a patron, go to patreon.com/sciencemom.
And don't forget that in the description of this video, there is a link to a worksheet where you can have additional practice problems to help you get good at identifying different geometric shapes.
Work hard, grow smart, and we'll see you next time.